आवाज आ रही है। सॉरी सॉरी। व्हाट्सअप फॉरवर्ड लिंक कर। हेलो हेलो हेलो। अभी आवाज आ रहा होगा, मैंने ईयरबड्स कनेक्ट नहीं करे थे। मतलब ब्लूटूथ से कनेक्टेड थे और बेस में मैंने सेट नहीं करा। ओके, हमने एक कॉल कर लिया है बेसिक था ये तो कुछ टॉपिक है। ठीक है। मैक्सिमम साइज रेक्टेंगल। मैक्सिमम एरिया। मैं टाइमर लेके आया हूँ यहाँ पे। पता है, मैंने एक ये डाला है यहाँ पे। ये हम हार्ड क्वेश्चन को 25 मिनट में आधा घंटा सही है। आधा घंटा दे। बंद रहा। हेलो 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 हेलो। और सब्सक्राइब कर देना आज। लेट्स सी हम 240 सब्सक्राइबर तक पहुंच पाते हैं। 240। सबसे पहला बोल रहा था 230 तक पहुंचना। 230 तक पहुंच गए मतलब मजा आ जाएगा। समझ रहे हो? 230 सब्सक्राइबर्स। लेट्स गो। हो जाए। फंड मिनिमम एरिया ऑफ द मैं क्या सोच रहा हूँ पता है? ये जो बनाया है जीरो वन वन इसका मैं ऐसा कर सकता हूँ या फिर मैक्सिमम भी लेंगे। ना दिल को तेरी हमारा टाइम भी दिल को तेरी रोज को मैं लगाने की कोशिश कर रहा हूँ। हिंट देखते हैं। मैक्सिमम रेक्टेंगल हिस्टोग्राम। इन सबको ट्रांसफॉर्म करके नीचे लेके आ गया। हम्म, ऐसा कर सकते हैं प्लीज। एक्सपेक्टेड टाइम फॉर दिस 3 4 3 2। हम्म, आई रियली वांट टू अंडरस्टैंड कैसे हो रहा है ये, कैसे हो रहा है। हम्म, कुछ तो आ रहा है। 2, 3, 4, 3, 2, 4, 4, 2. 2, 2, 4, 4, 3, 4, 2. और 0. तो 2, 4, 3, 4. तो अपनी लिख को छोड़ के oh yes, I got it. इसके लिए फिर हम प्लस करेंगे। ओके, सारी इसके लिए हम जी देखो भाई, ये किया। ऐसे 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 मैट्रिक्स किया। into row plus equal to matrix I कौन हो जाएगा? कौन इसकी जगह कौन इसकी जगह हाय जगह है, ठीक है। हम्म, बढ़िया। तो कुछ कॉल कॉल चलो चलो और मुर्गों का लंच ऐसे जो है ना, तो उनका लंच और कॉल का लंच ये है कि ओके रिटर्नलाइज करते हैं और ये सब तो आता रहता है, इसमें कोई दिक्कत नहीं, कोई दिक्कत नहीं है भाई, कोई भी दिक्कत नहीं है। कुछ लाइफ में मॉडिफाई कर दे तो क्या आएगा? इनको तेरी हम्म, कितना हमारे पास टाइम बचा है? 5 मिनट बचे हैं। लैपटॉप सो रहा है ना? फिर से उठाया। कितना टाइम बचा है हमारे पास? 4 मिनट। 4 मिनट में क्या सोची रहे? मतलब क्या किया जाए? कुछ दिखा यार इसका इम्प्लीमेंटेशन, जैसे कि रो वाइज कुछ कैलकुलेट करना है, कॉलम वाइज कुछ कैलकुलेट करना है, फिर कुछ निकालना है। कैसे किया जाए? हम्म, भाई हमें पहुंचना है ना 230 सब्सक्राइबर्स आज पहुंचना है। क्या लगता है दोस्तों, पहुंच जाएंगे हम? 230 सब्सक्राइबर्स। लेट्स गो। लाइक करो यार, लाइक भी करो, लाइक भी करो। टाइम इज अप हो गया। मैंने सबमिशन तो कर ही रखा होगा, इसका नाम क्या रखा है? फाइंड मैक्सिमम एरिया फॉर रो जीरो। For each row, I want to animation. For each row, each column in that location. So रो कॉलम वन है तो अपडेट ए ऑफ रो कॉलम विथ रो माइनस वन कॉलम। फाइंड एरिया and area for that row. What do you mean by area? ओके, तो अगर मेरा ऊपर वाला वन है, जो भी है, वो रो जीरो का मैक्सिमम काम करना है for each column in that row. Find maximum area for row zero. What do you mean by that? रो जीरो को मैक्सिमम एरिया मान लिया ऐसा। फिर हमने तो मैक्सिमम एरिया फॉर रो जीरो टू, दो है दो, फिर वन से चले, वन से चले, फिर क्या किया, सारे कॉलम तो इसको कर दिया हमने टू, टू कर दिया। फिर मैक्सिमम एरिया फॉर दैट फोर, फोर आया। फोर आया। क्या किया अगर तो ये क्या होगा, पाई होगा। अब इसके लिए एरिया ढूंढेंगे तो एक थोड़ी नहीं होगा। मिलेगा। मिलेगा। तो हर एक पॉइंट पे हिस्टोग्राम लगाना है इसमें। ऐसा खेल। आई थिंक ऐसा ही है। ऐसा ही खेल है कि हर एक पॉइंट पे हमें हिस्टोग्राम लगाना है। प्लीज भाई थोड़ा लाइक वाइक करो यार। लाइक नहीं देख पा रहा हूँ। तो हिस्टोग्राम वाला भी मुझे तो याद नहीं है। अरे यहाँ है जी यहाँ। तो मैक्सिमम एरिया होगा मेरा। थ्री माइनस जीरो प्लस वन इंटू आई जी। तो बढ़ता कौन है, छोटा वाला बढ़ता है आगे या बड़ा वाला आगे बढ़ता है? ये छोटा वाला ही बढ़ेगा। जी आते हैं। तो अपने को 9 मिलेगा। ठीक है। फिर कोई भी बढ़ा लो इसमें से। कोई भी बढ़ा लो। ठीक है, कर सकता हूँ मैं, इजी है। हम्म। देखिए एक कैलकुलेट हिस्टोग्राम करके फंक्शन है। सबसे पहले बेस लिखते हैं। ठीक है, इंट रेस इक्वल टू। ठीक है। जिसमें जिसको बोलते हैं हम कैल हिस्टो। इसमें जाएगा रो नंबर, जो कि पहले ये जाएगा, फिर जाएगा मैट्रिक्स, फिर ये जाएगा, फिर जाएगा मेरा जीरो, फिर जाएगा मेरा n-1। करेक्ट। ये करेंगे हम। अब हर बार ये चलेगा फर्स्ट रो पे। ठीक है। तो if match of I-1, comma 0 is 1, then match of ij equal to plus equal to 1। ठीक है। अब यहाँ से हम बाहर आ गए। यहाँ से हमें करना कुछ नहीं। यहाँ से हमें int area न्यू area जो कि हो गया कैलकुलेट हिस्टो जिसमें जाएगा मेरा रो मतलब आई मैट्रिक्स जाएगा जीरो जाएगा माइनस वन जाएगा और रेस जो है मेरा मैक्स ऑफ रेस कॉमा न्यू होगा फिर हमने यहाँ से रोलिंग बन किया यहाँ से हमने ये तो हो जाएगा हमको कैलकुलेट हिस्टो और यहाँ के बाद कैलकुलेट हिस्टो इसके अंदर आएगा मेरा रो आने का फिर आएगा वेक्टर ऑफ वेक्टर ठीक है मैच और आएगा आई और आएगा जे बराबर अब वाई लेस देन इक्वल टू जे एंड रेस एरिया क्या हो रहा है जीरो और मुझे करना है रेस एरिया इक्वल टू मैक्स ऑफ रेस एरिया फ्रॉम j minus I plus 1 into minimum of not of row considerable row of I mat row of j बिल्कुल सही है और if mat row of I is less than mat row of j then I plus plus else j minus minus return res area हाँ अब अब यहाँ पे दो ही है सही है। हम्म आओ 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 किया जाए 0 1 1 0 के लिए सबसे पहले हमने कैलकुलेट करा तो आई 0 होगा तो फिर क्या होगा जे माइनस 0 जे यहाँ फिर वापस एरिया कैलकुलेट किया तो 0 आई यहाँ फिर हमने एरिया कैलकुलेट किया जी माइनस आई प्लस वन यानी टू इंटू मिनिमम फाइव जी जो कि होगा फिर एज एरिया आया मेरा टू ठीक है अब एज एरिया जी माइनस वन तो वापस मेरा रहा जीरो क्या है, 1 1 3 1, लेकिन मैक्स ढूंढ रहा था तो इसने 2 रिटर्न किया। तो अभी मेरा रिजल्ट है 2, 1 2 2 1 2। ये ऊपर वाला अगर यहाँ तो प्लस इक्वल टू 1 हो जाए। कर ही देते हैं, ये इसमें से दिक्कत तो नहीं आ रहा, नहीं आना चाहिए। इसने रेफरेंस पास कर दिया। ठीक है, इसके लिए कुछ ध्यान देता है। आई यहाँ पे, जे यहाँ पे, तो मेरे रिजल्टेंट क्या होगा। कोई ऐसा ये आ गया तो क्या हो जाएगा, खत्म हो जाएगा कोड मेरा। ये सही तरीका नहीं है हिस्टोग्राम का कोड लिखना। डीपी की लगा लोगों ने। स्टैक बनाया है और पीछे से जा रहे हैं इसमें। ठीक है, पीछे से जा रहे हैं और साइज बड़ा करेंगे। साइज को है तो सबसे पहले मैंने सीखा है। कैलकुलेट हिस्टोग्राम वाला देखना पड़ेगा। यूट्यूब। ये देख रखा हूँ।
width 2 and height 5, which makes it an area of 10. This is the largest that you can get. Now you don't have to worry, I've already made a video on this. Like if you see on the screen, there's a video which is already. So let's continue with our stack and cube playlist. It was starting off. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is maximal rectangle. So what is the problem stating?
Bro, are you watching in 2x? 2x में देख रहा हूँ.
Problem stating that you will be given an n cross m 2D matrix which only has 1 and zeros in it. Now your task is to give me the area of the maximal rectangle which has all ones in it. The area of maximum rectangle in this 2D matrix which has all ones in it. Let's understand. Can I take this particular rectangle? Yes, because it has all ones in it and it is a rectangle. If I figure out the area will be 5 because it is 1 cross 5. 1 is the height, 5 is the width. So this is the area. But you'll have to figure out the largest, the maximal area. Do I see any other rectangle? Yeah, I do see this one, which is having an area of 6 because 2 cross 3.
सिर्फ
This
उसको
is the
हम
maximum. You look over.
Are you grad? हाँ. Yes, I'm grad.
So let's continue with our stack and cube playlist. It was starting off. Hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is largest rectangle in a given histogram. So you will be given an array of integers where every integer is representing the height of a given bar in a histogram. So the height is given to you and the width is constant. The width will always be 1 for every bar. The width will be constant. Now your task is to return me the area of the largest rectangle that you can form in a given histogram. So what is a rectangle in a histogram? So if I stand at 1, the rectangle that I can form is this one. And I have to figure out the area of this rectangle. I can say that the width is 6 because it has 6 blocks. Every block has a width of 1, thereby 6, and the height is 1. So the area will turn out to be 6. But you need the largest. So can I say that if I take the height of 2, I'll be able to form this particular rectangle, and the width will be 4, the height will be 2, which will give us an area of 8. Is this the largest? No. If I take the height of 5, the bar 5, then I can form this particular rectangle, which has a width of 2 and a height of 5. So 5 cross 2 will be 10, and this is the largest that you can form. And this is what you'll have to return. 10 is the value that you will have to return. How do I solve this problem? So the extreme naive solution will be, I'll go to every bar, I'll go to every block, and at every bar I'll be like, what is the maximum? Like, what is the largest rectangle you can form? For example, when I go to 0, like the 0th index, it has a height of 2. It cannot form like 2 on the right. So I know this particular one can form this rectangle itself, which is having a height of 2 and a width of 1. 2 and 1. So 2 plus 1 will give us an area of 2, correct? And then when I go to 1, I ask, what is the rectangle? Like, what is the max rectangle you can form? He's like, okay, I can go till right and I can go to left. And this is the rectangle I can form, where this is 6 and this is 1. So I can go ahead and do a 1 height and a 6, which makes it a 6 area rectangle. I go to this one. I'm like, okay, I have a height of 5. I cannot go to the left, but I can go to the right. Therefore, I can form this particular rectangle, which is an area of, yes, a height of 5, and a width of 2, an area of 10. I'll go to the next one. I'll see that it has a height of 6, so it cannot go left, it cannot go right. So it'll have a height of 6 and a width of 1, so the area will be 6. Then I go to this one, which has a height of 2, can go right, can go left, only up to here. So this is the rectangle it will form, which has a height of 2 and a width of 4, which is 8. Then I'll go to the next one, which has a height of 3, cannot go left, cannot go right. So this is the only rectangle.
You know, when we talk about resumes, adding Microsoft Excel as a skill might land you a job with a 4 to 5 lakh per annum salary.
It can form, which is a height of 3 and a width of 1, makes it a 3. If I ask you which is the largest, it'll be like the largest is 10. All I did was, I went through each and every bar, each and every index, and I gathered the largest rectangle that they can form. And out of all of them, I did the max out, and this is what I will be returning. Now the main question is, how do I know? Okay, I think you got the intuition. When I'm standing at 2, there is a reason I cannot go right. There's a reason I cannot go right. Because right after 2, there is a smaller element. So I cannot continue this block 2 stuff. Okay, makes sense. If I'm standing at 5, I know I can go till here. Why? Because on the right I have a greater element. So I can go. But beyond it I cannot go because I have a smaller element. And on the left, I cannot go because I have a small element. Okay. If I look at this one, which is a height of 2, I can go till the right, till the last. But I cannot go on the left because there is a small element. So can I say for every block, I can go till the small element is encountered? Till the small element is encountered. Okay, I got an idea. So what I have to look over here is whenever I'm standing at a particular bar, a particular block, on the right, I can go till the next smaller element, the element smaller than 5, because till that I can form the rectangle. And on the left, I can also go to the element which is smaller than 5, because I can form the rectangle till that place. I can, if it's a height of 5, I can just carry on. And if there is a smaller, it will break. On the left, I can carry on. If there is a smaller, it will break. And this is how the rectangle will be formed. So what I typically need is previous smaller element for every block. I need to know it. Next smaller element for every block. I need to know it as well. Okay, that's understandable. So before I move on to previous small element and next small element. So this is an entire playlist of stack and cube. I've already taught NGE. I've also taught PSE, which is previous smaller element. So please go back and watch those videos, because if you know NGE, you can also write NSE. It's very straightforward. So we know NSE, we know PSE, which is what we need. Next smaller element and previous small element. That is all I need. So because I already have made videos on it, I'll not be repeating it over here. Please go back and watch it if you haven't seen it. Perfect. So can I say this? That if I know the previous small element, if I know the previous small element for everyone and the next small element for everyone, the indexes. So let's take an example. Imagine I'm standing at this particular thing. For this one, where is the previous small element? That's this. This is the previous small element. Where is the next small element? I can say somewhere here, which is an imaginary index because it doesn't exist. Okay. So I know for sure I can go till here. I can go till here. So this is till the place I can make the rectangle. Now what I know one thing for sure, the height. The height will be 2. I don't need to do advanced maths to find the height. So I will be height, which is area of I. Area of I will be height. What I need is the width. Can I say the width is of 4, which is nothing but 6 minus 1, 6 minus 1 minus. Can I say this? I can, which is typically next small element, because that is on the right, minus previous small element, which is on the left, minus 1. And this will be the area of every ith block. So if I can get for every ith block, I know I can easily figure out the max from I equal to 0 till n minus 1. All I need is the previous small element, which I know how to find. All I need is the next smaller element. Remember, if there is no previous small element, please assign minus 1. And if there is no small element, please assign the size of the array, which is n. So if you see, for this particular 2, I didn't have a next small element, so I assigned 6, which is typically n. Just keep that in mind. So if I have to write down the code, I'll not be writing down the code for previous small element and next small element. You can find them below, or you can go back to the previous lecture and you can watch it across. So we straight away writing the functional code, or rather the pseudocode. So I'm given a function, I'm given an array. That is all I have. Now what I need to do is, first and foremost thing what I'll do is I'll figure out the NSE by calling find NSE for this particular array. I'll also figure out the previous small element, which is PSE, which is find PSE. And then I'll assign a maximum to be 0 because I haven't found any till now. So the maximum area to be 0. Then I'll grab this from 0 till n minus 1. Now what I will be writing is, okay, I know one thing. The area will be array of I multiplied by next small element of I minus previous small element of I minus 1. So this will be the area, correct? And I need to compare it with maximum. So maximum equal to max of maximum comma this and comma this. That's it. And eventually you could end up returning the maximum. Done and dusted. So if you know next smaller and previous smaller, which I've already taught, this problem is a cakewalk. And this is the brute force. So time to talk about the time complexity. Can I say that the time complexity will be 2 cross y2 because I'm finding next smaller and previous smaller. So both of them use the same logic. So I've done 2 cross. And individually they take a time complexity of bgo of 2n, right? The stack solution. So this is taking bgo of 2n. So this is in total bgo of 4n, correct? And this is in total a time complexity of bgo of n, which makes it a total time complexity of bgo of 5n solution. You can also determine the space complexity. I'm using a bgo of n here, a bgo of n here, which is a bgo of total of 2n. Plus we'll be using a stack for this one, which is another bgo of n, and a stack for this one, which is another bgo of n. That's a bgo of 2n plus 2n, near about bgo of 4n. Okay, so this is where the interviewer will not be happy because we're kind of using a 2-pass solution. First we are figuring out the next smaller, then we are figuring out the previous smaller, and then we are doing a computation. The interviewer will step in and he'll ask you, can you do it in a single pass? No pre-computations. Can you do it in a single pass? So we need to optimize the brute force solution. And the brute force what we did was, we went to each and every element and then we applied this particular formula. In order to apply this particular formula, we needed to pre-compute next smaller element as well as previous smaller element. Now we're not allowed to pre-compute both of these things. We're not allowed to pre-compute and pre-store. So can I do it without pre-computing, without pre-storing is the question. Okay. One thing I know for sure is, I'll still go through each and every element. Why? Because if I do not see the entire data, if I don't see the entire data, how will I solve the problem? So I'm very sure that I'm traversing every element at least once. Otherwise I will not be able to see the entire data. And I need to see the entire data in order to solve the problem. So I'll be traversing through each and everything. So one part was traversal, which is done. Now whenever I'm at 5, what do I need? I need the next small element and I need the previous small element. Can I say one thing for sure? This would be computed. This would be computed on the fly. Why? Because if I'm traversing from left to right, I can take a stack and I can apply the previous smaller element concept. So whenever I'm at 5, I will know who is the previous smaller element of 5, who is the previous smaller element of the 5, because while traversal, I can use the previous smaller element method and I can keep it. So I know how to compute it without restoring. But the problem is, because I'm at this particular index, I haven't visited them. If I haven't visited the right part, there's no way I'll know who is the NSE, who is the next small element, because I haven't gone to them. How will I know who is the NSE? And this is the problem that I'll have to solve. So the intuition is, somehow I should have gone to them. Then while coming back, that's when I do the trick. But do I come back? That's the question. Do I come back? We will see. So let's quickly do the dry run. So what I'll do is, I'll try to do the on-fly operation for previous small element. And while doing the on-fly, I'll try to do this particular formula for each and every element. Let's see how. So I'll be storing the indexes. And in order to understand, I'll be storing the val on the side, just to understand, not in the code. Okay, so the first element I go towards the 0th index, which is having a 3 value. So the stack doesn't have anything. So just put it into the stack and the value will be 3. That's it, done. Next, I'll go to the next. Now this time the stack has a value of 2. Do I enter 2? Like, do I insert 2 into the stack? If I'm computing previous small element, I need the previous small element of 2. So 3 cannot be the previous smaller. So I'll kick out 3, I'll kick out 3, because 3 cannot be. So I have to kick them out, I'll have to kick them out. So I'm kicking them out. 3 is gone, 3 is gone. But before kicking them, why am I kicking them out? The reason is 2 is smaller than 3. 2 is smaller than 3, and that's your answer. Can I say if 2 is smaller than 3? That is why kicking, because you need previous smaller. And for 2, the previous smaller is this, which is -1. That's why you're kicking this out, right? The concept of NSE. So can I say, if I'm kicking out 3, can I say this? The 2 is nothing but the next smaller element of 3. I can. This 2 is the next small element of 3. I can see that. So I have it. For 3, who's the next small element? Ideally, if it is in the stack, the previous element to it will be the next small, and it doesn't have anyone. So can I say that there's no previous smaller element to 3? Ideally, I'm at this particular bar. Ideally, I'm at this particular bar. So what that means is I've traversed this portion. I've traversed this portion. But now, when I'm taking this 3 out,
let's play a game. Give me 40 seconds. Trust me, it's going to be fun. So, imagine.
I'm having a hold of 3 and taking it out. So while taking it out, that is when I compute this formula. While coming back, I do the computation, because I know now what is the next one, because I've seen the right and what's the previous one. So can I say for 3, I can say 3 multiplied by, what am I, where am I? I'm at the index I, which is 1. That's the next one. This formula. For 3, who's the next small element? Ideally, if it is in the stack, the previous element to it will be the next small, and it doesn't have anyone. So can I say that there is no previous smaller element to 3? Ideally, I'm at this particular bar. So what that means is I've traversed this portion. But now, when I'm kicking this 3 out, I'm having a hold of 3 and taking it out. So while kicking it out, that is when I compute this formula. While coming back, I do the computation, because I know now what is the next one, because I've seen the right and what's the previous one. So can I say for 3, I can say 3 multiplied by, what am I, where am I? I'm at the index I, which is 1. That's the next smaller. I don't have a previous smaller, so that's -1. I do -1, which makes it an area of 3. So what I can do is I can keep a max area variable, and I can initialize 3 to it. Perfect. So I'll kick out 3 because done. Remember, I touched 3. So you could go ahead and kick out 3, done. And since the stack doesn't have anything, just insert the index 1 to it. So you end up inserting the index 1 with the value 2, and then go to the next. Next value is 10. Don't do anything, just push it in, because for 10, do you know what's the next? The previous small element? You don't know. That's the previous one. That is already there in the stack. And you just keep maintaining the order. Keep maintaining the increasing order. That's what you do. Perfect. You will not compute for 10. Because you don't know what is there on the right. In order to compute for 10, you need the next as well. So don't compute as of now. Put that in. Perfect. And then go to the next. Again at 11. You know, for 11, the previous small element is there in the stack. So just put that in. Put that in index 3 and 11, and then go ahead. You go ahead to 4. And this is where you need to understand. You're at 4. You're at 4. Which is having a value 5. 5's previous is what you need, because you're implementing the logic of previous small element. 5's previous is what you need. So when I'm looking at 5's previous, I'm like, there's 11, which cannot be. There's a 10, which cannot be. 2 can be. And which is actually true. So what I'll do is I'll end up taking this out. I'm traversing back. So I'm traversing back.
और 10 और 11 और 10 के लिए भी
11 goes out, which means
11 और 10 के लिए भी 11 और 10 के लिए भी हमें नेक्स्ट स्मॉलर एलिमेंट मिल जाएगा.
I'll be doing the operation for 11. Coming back and coming home. The reason I'm coming home is I got someone smaller than 11. So can I say this 5 can be said as the next smaller element for 11? I can say that. And for 11, can I say the previous smaller element is stored in the stack? Yes. So 10 is the previous smaller element of 11. So I know for 11 multiplied by, where is 5 at the index 4? Where is 10 at the index 2? A -1. So you could do it. And the answer will boil down 4 minus 2 is 2 minus 1 is 1. It will boil down to 11 will be your max area. So you could update this to 11. Perfect. So you've touched 11. Remember, you've touched 11. So you could just kick out 11 now. So you've touched 11. Now the next thing is I'm still at 5 and I need the previous smaller element of 5. For that, I'll have to kick this out as well. So again, I'll kick this out. So when I kick this out, can I for sure say that 5 is the next smaller element of 10? I can surely say, because that is why I'm kicking. And can I say that the previous element in the stack, which is 2, 2 is the previous smaller element of 10. So again, can I say this? That I'm touching 10 because I know the previous smaller, I know the next smaller. So the area will be 10 cross. Can I say for 10, this is the next smaller? Yes, which is at index 4, which you're storing, minus the previous smaller element is at index 1. So you could typically do this, which gives you an area of 20. You could just update that area of 20, which is logical because it will just be this one. Right? Perfect. So done for 10 as well. So you could just go ahead and erase 10.
Nice.
So if you see, when I was at 5, I ended up kicking these two out. So I went back. So while I went back, because they had a front view now, so I could easily compute for 10 and 11. So the next thing will be, I'll take that 5, I'll insert it, index 4, and I'll go to the next. Next is 10. So again, you just take it because you want to maintain that order. So the element is 10. It's having index 5, so you can just place it across. Next, you go to 6. Now this time when you are at the index 6, which has a value of 6, you need the previous smaller, which is over here. So you need to kick this 10 out. Take it out now. Why are you waiting? Kick it out. So just kick that 10 out. So I'm taking that 10 out. Can I say that again? 6 is the next smaller element of 10? I can. And to get the previous smaller, can I say 5 is the previous smaller element of 10? I can definitely say that. And right after this, if I need to find the area, it will be 10 multiplied by 6 is the index. 5 is at index 4, minus 1. That's going to be 10. Yes, 10 is the area. Will it update the max area? No.
Nice.
So done. So we're done with 10. So I've also touched 10. So what I'll do is I'll go ahead and touch 10. So you're saying I'm touching every element once. Okay, press. Next, will I insert 6? Yes, because it is maintaining the order, so you can insert 6 as well as the index. After that, you'll go to the next, which is having a value of 3. And for this 3, if you carefully observe, the previous element is 2. It can actually form a rectangle till here. If you carefully see, it can form a rectangle till here. Okay, so I know one thing. The previous element is here. I need to kick them out. In order to go there, I have to kick 6 out and 5 out. Then only I can go till 2. So I'll kick them out. first thing I'll do is I'll kick 6 out. So I'm kicking 6 out. Remember, you're touching 6 as well. You're touching 6 as well. So again, you can say that 3 is the next smaller element of 6. At the same time, you can say that 5 is the previous smaller element of 6. It is a valid thing for 6 multiplied with where is the 3, index 7, where is 5, index 4. So you can just straight away write 5 and you can do this. That will give you 12, which doesn't change the max area. That is that. So I kicked out 6 as well. So I've touched 6. Will I kick out 5? Yes, I'll kick out 5. So you'll just kick out 5 as well. I'll end up touching 5 as well. Amazing. I end up touching 5. But this is when I can say that 3 is the next smaller element of 5, which does make sense if you see. Which does make sense. And if you see the previous, which is 2, that also makes sense. So I can say that 2 is the previous smaller element of 5. Thereby, I can say 5 multiplied by 3 is at the index 7, 2 is at the index 1, minus 1. Makes it a max area of 25. Thereby, I can update this to 25. And after that, I'm done with 5. So I've touched 5 as well. After that, I take the index 7, I insert it, and I go off. I'm done. I'm done. There are still elements left out to be touched. Which are those elements? 2 is the one which I haven't touched, and 3 is the one which I haven't yet touched. But according to our brute force, I'll have to touch each and every element and apply this particular formula. Correct? So if I haven't touched, what does it mean? It means for this 2, if you see there's no smaller element, there is no next smaller element. Okay. For this 3, there is no next smaller element. So if there are elements still left in the stack, which that really means there are no next smaller elements. So you could end up taking the hypothetical index as a next smaller element for them. But for this 3, I can say that we do have a previous smaller. But for this 2, I don't have a previous smaller. So I can take a minus 1 for this 2. Perfect. So once the iteration is over, if there are elements left in the stack, do an individual iteration. Get the first element out. The first element is 3. So I can say that 3 is the element. I know the right index. It doesn't have an index smaller. So I can take the extreme length 8. I can take the previous, which is 1, which is this one. 1 minus 1. That will give you 18 size area, which does make sense because if I go to here, this is 6 blocks into 3. 18 size area. Does make sense. That is not the max. So we're done with this as well. So we are very sure that we have touched 3 as well. Let's come to the last element, which is this one. I can say 2 multiplied by the right, which is at 8. And since there are no elements in the stack, on the left it will be minus 1 and minus 1. It gives you a 16. Does make sense because 2 will go to here and 2 will go to here, which is 8 blocks, and the area will be 16. So I'm done with this as well. So the stack is empty. Once the stack is empty, I can say that I've touched 2 as well. And if you look, actually I've touched everyone. And you've applied the formula for everyone. And you got the max area to be 25. So this is what you will be returning. So you just need to keep in mind, if you can just apply the previous smaller.
तो बिल्ली के बाल लग गए दोस्तों। जी हाँ दोस्तों।
You have context about the back. All you need is the forward context, and that can easily be done while popping out. Very simple, isn't it? So it's important to understand the concepts in depth. So we will be writing down the pseudocode. So we're given a function and we're given an array. So initially what I can do is I can define a stack and I need a max area. So maybe I can define a max area to be 0. So what we do is we start traversing from 0 till n minus 1. So let's do that. It's going to be for I equal to 0 till n minus 1. I'm implementing the previous small element code. So I can say, hey, listen, if the stack is empty, which is the standard thing, and whatever is the element at the stack top. Remember, whatever is the element at the stack top. If that is exceeding my value, that's it. This is my element. Remember this. And you go to a stack.pop. Whenever we come back and pop out, because we're popping out a data element, that becomes my element for which I'll compute the area. So I know my element for sure. What I need to know is, who is my next smaller? I know the next smaller is the current index I. And who is the previous smaller? I know the previous smaller will be the previous element in the stack. But what if the stack is empty? The stack is empty, I'll take minus 1. Otherwise, I'll say whatever is the previous element in the stack. Whatever is the previous element to this, right? So I'll get the NSE and the previous element. So what is the area? Can I say the area will be element into next smaller minus previous smaller minus 1. And since I'm computing max area, I can do max area of max of this comma max area. I can do that. Perfect. And that will wait for this particular while loop. Remember, you will be pushing the index, not the value. You'll be pushing the index and not the value. So for that reason, this won't be element. Rather, this will be array of element because we're storing indexes. So get the element out by doing an array of element. Perfect. So that's done. But what if there are elements left over? So you'll still have to run a while loop for it. So if there are elements left over, you will say while the stack is non-empty. And no comparison this time. You can say that the NSE for sure is n because these elements don't have any small elements. I can take it as n. What about this particular element? So can I say that this particular element is st.top and I can do st.pop. So we're done. Now I need the next small element. So previous small element. Previous small element is nothing but whatever is on the stack as of now. If this is -1, it is empty -1. Otherwise, I do a stack. And after that, I could do the same thing. Max area is equal to max of max area, comma NSE minus ESE minus 1 multiplied with array of element. And that's it. And eventually, you could end up returning max area. And we are done. So time to compute the time complex.
आप कंप्लीट करते हैं हिस्टोग्राम। while यही देना है मैट्रिक्स जैसे मेरे ARR आए लेस देन हो जाए मैं स्टार्ट टॉप से हाँ तो हम क्या करेंगे ये सबसे पहले मेरा होगा स्टार्ट टॉप ठीक है फिर करेंगे स्टार्ट टॉप ठीक है नेक्स्ट स्मॉलर एलिमेंट जो है मेरा प्रीवियस स्मॉलर एलिमेंट होगा मेरा रेस डॉट pt है तो -1 होगा वरना हैश डॉट टॉप होगा ठीक है हैश डॉट पुश होता है ना हाँ ठीक है अब क्या है अब क्या बाकी नंबर बच जाएंगे while max area trace area comma PFC minus MC minus 0,8 मतलब ये ये इंट ईयरली होगा मेरा एच डॉट टॉप एच डॉट पी ठीक है नेक्स्ट स्मॉलर एलिमेंट होगा मेरा एन साइज ठीक है ये वापस ये वाला Oops. फॉर लूप पे चलाया ही नहीं अपन और इसके अंदर ही ले लिया शिट अब सही है ओ काफी ज्यादा टाइम चलेगा यार इसमें तो अपने हम्म, ज्यादा ज्यादा यहाँ पे एमएससी माइनस पीएससी एमएससी पीएससी कहाँ दिक्कत आ रही है समझ नहीं पा रहा एक क्वेश्चन में 12 बजा दिए उसका
What about
कोड
this
अगर
particular element?
टॉप अगर बड़ा हो, किसने यहाँ पे कमेंट में कर रखा है? उल्टा क्यों जा रहा है? ये तो एग्जैक्ट है। हिस्टोग्राफी क्या है? हिस्टोग्राफी बताया अलग है और समझाया अलग है यार। नेक्स्ट वाला Mainspring is small. Really is as the top. समझा इसका रेंज ही जीरो आ रहा है तो ये वर्क नहीं कर रहा है ये वाला जो कैलकुलेट वर्क इसलिए नहीं कर रहा है मैं सी जो हेलो जो की सवाल को पढ़े हुए हैं कैलकुलेट तो जीरो जीरो तो बन गया जीरो बैक तो वन के लिए थ्री दी है थ्री आर तो ARR of 3 is less than ARR of first person तो ARR में ये रिड्यूस में अच्छे स्टॉप ले लिया जो कि है मेरा वन ये अब ये MSC है ना MSC अपने को आई ही रखना हाँ कि मेरे अपने को थ्री मिलेगा कोई से भी हो तो भी पास करना पड़ेगा जीरो से गया ठीक है अंतिम हमें तो स्टॉप में जीरो हो गया ठीक है फिर ये तो क्या है ARR of I यानी वन उसको टॉप से उठा फिर वन गया फिर गया निकल जाएगा कोड कर पाएगा ये गया टू है फिर आई जीरो जीरो का छोटा आया तो हमने क्या किया एलिमेंट को रखा ARR of ARR of 2 MSC को रखा हाई और यानी 3 PSC को रखा उड़ा देना बाहर 1 रखा कौन वाले में क्या हो गया ARR of 2 रखा है यहाँ पे एलिमेंट सी हमने रखी अब ये प्रीवियस वाला सी वो बराबर भी आता है नेक्स्ट स्मॉलर रखना चाहिए नेक्स्ट स्मॉलर फिर कैसे निकालेगा
सारे आंसर is everyone who is multiple for
रोटेट करना है 90 डिग्री, कैसे होगा? कैसे होगा? प्रोग्रेस अपडेट नहीं किया मैंने। किया। This is overseas 9. Rotate it by 90 degrees clockwise direction without using extra space. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Sign up speed. Got it. ये क्या है? इसको मैं 9, 4, 8, 2, 3, 6, 9. अगर इवन हो जाए तो रो एक्सचेंज करना बेटर रहेगा। तो इसको छोड़ के, बीच वाली इसको छोड़ के हम बाकी का एक्सचेंज करेंगे और फिर रो एक्सचेंज करेंगे। ठीक है, तो एक ही करके देखते हैं पहले। यहाँ आएगा 16, फिर 12, 15, 14, 11, 14, 10, 7, 4. Then 9, 5, 9. 2, 6. You were supposed to be writing another word change for now. 5, 1, 14, 10, 6, 2, or or but yeah, 15, 11, 7, 3, 16, 12, 8, 4. Okay. So whether you are IGN, so you know 4 minus 5, 4 minus 2. 4 minus 3, 1.0. Variable 4 minus 1. Let I greater than 0. Let I be I greater than 0. Yeah, greater than 0. I will less than 0. Then 0. The exchange is 5. GP 5. Minus 1. Comma. It's very right. Probably. It's not so much. 2 minus 1 is 3. Or G. 3 minus 0. Okay. That thought. Again. I plus plus ठीक है, आई प्लस प्लस फिर अंदर एक और जी जीरो प्लस जी प्लस प्लस if I plus j not equal to equal to n minus 1. So that's what I achieve. So minus j minus 1 minus I. ठीक है, for I equal to 0 plus plus यहाँ पे हमने सारे रोज को एक्सचेंज करना, एक रोज है इसमें जाके जाएंगे तो इनपुट में जाएगा, ये जाएगा लेस देन